So in this video, we're going to complete two problems on page 99 in your workbook. These two problems are a continuation of the work that we did last Thursday. So if you look for the opening activity from September 11, September 12, these two problems will look a lot like problem number 5 on that activity. So problem number 1 says draw a segment, label the endpoints A and B, rotate segment AB clockwise around center B by 9 degrees, label the new endpoint A prime, connect the 2 points A prime, and then what is here the triangle. What type of triangle do you have? So if you would go ahead and complete this construction. And then turn the video back on when you're ready to continue. So in this problem, like problem number 5 from last week, if you're doing a rotation, again, you need to know direction, you need to know the point you're rotating around, and you need to know angle measurement. Or if you don't know the angle measurement, then you're rotating from what point to what point so you know when to stop the rotation. So if we're rotating point A, that means we need to construct a circle where center of the circle is point B, and then point A, we're moving point A on this circle, so the radius of AB and radius of BA prime will be the same distance. So again, point A prime is on the circle. So step 1 we talked about last week is you need to draw a circle through the point. You need to draw the segment or the radius, because we use that actually to measure the angle. And then the angle we're given is 90 degrees. So we'll set the protractor up, and then we're going to mark 90 degrees. And then we're going to draw in the other radius. BA prime. So these two should be the same length. And the last step asks you, step B asks you to draw in this segment, AA prime, and then lightly shade the triangle. So this will be the triangle, and then asking you to name it. What kind of triangle is it? What's its properties? So whenever we name triangles, we try to, if it's possible, name it with its 2 names. All triangles have 2 names. We refer to it by its side. So is it equilateral, isosceles, or scaling? And is a triangle a right triangle, acute triangle, or obtuse triangle? And again, if we can name it by both side and angle names, that's the best angle or best name you can give the triangle. So this problem here, because you have 2 equal sides, and it's not equilateral, but so it's triangles isosceles. And because we did a rotation of 90 degrees, that means the angle at B is a right angle. So this triangle is an isosceles right triangle. Properties, so you have 2 equal sides, you have a right angle. Another characteristic of this type of triangle, you'll notice we have two angle A's. One is A and one's A prime. So based on the shape of the triangle, what do you think is true about the 2 angles at A? So take a moment, think about that. You have a protractor, got patty paper. What do you think is true about those 2 angles? As again, is another property here. So I'll give you a few seconds to work through that, and then I'll continue the video. All right, so if I trace the triangle on patty paper, and if I would actually fold the triangle, the two angles actually match up. So they're actually congruent. So not only do we have two equal sides, but we also have two congruent angles. So isosceles triangle, two equal sides, also two equal angles. These two angles down here, which we call this the base angles, will be the same. And of course, it's the right triangle because of the construction. I'll go ahead and complete the second problem. This is some very similar steps in problem number 2. And then this time we're doing two translations, or two rotations to get the resulting triangle. So we start off with a segment CD, and we're rotating around D. So complete the problem when you're finished, and then turn the video back on. Alright, so like the previous problem, we need to draw a circle. It's asking to rotate around point D, so that means D is going to be the center, and the circle itself needs to go through point C. So that's our first step, is drawing the circle to the point we're rotating, and then make sure that the other point is the center. We need a radius because we need a side to draw our angle. It's asking you to do a 30-degree angle. We're going to set this up for a 30-degree angle. And then we're going to draw on that radius. Let's call this C prime. And then we're being asked to do it again. Another 30-degree angle. And this time it's going to be D C double prime, because this will be the second time we made this rotation. So C prime first time, C double prime second time, again another 30-degree angle. And then ask you to draw in C double prime. Lightly shade the triangle. And indicate what kind of triangle it is. So again, we're going to do the same exercise as we did problem number 1. We know both of its names. So hopefully you decided that this is a acute triangle. So all the angles are definitely less than a right angle. And the triangle actually is acute. I'm sorry, is equilateral. All three sides are actually equal. They're actually equal. C and C prime are actually the same measurement as the previous problem, or A and A prime. And from the video from last week on the day I was gone, this particular triangle came up with the isometric paper. And so in that discussion, she talked about the fact that all the angles are actually all 60s. So it's an equilateral triangle, all the sides are equal, all the angles are equal. So one thing to keep in mind for triangles, if you have for equilateral, you have 3 equal sides. But you also have 3 equal angles. And for isosceles triangles, you have 2 equal sides, or at least 2 equal sides, and 2 equal angles. So the number of it's only true for triangles. The number of sides that are equal and the number of angles that are equal are the same number. Alright, this is it for this lesson. You should have another handout that you were given by your teacher called Unit 1, Lesson 14.3. Are you ready for more? And so on that activity, you're being asked to complete 2 of the 3 constructions. We've done one of them multiple times. and the other two are new, but thinking about this idea of rotation, can you come up with a method that will allow you to construct any regular polygon that's possible? Sometimes some of the angle measurements you're using may be difficult to actually measure accurately, but these three here are pretty easy to do in terms of their angle measurements. So complete the activity in class today. If you don't get it done, you'll have some time to complete it